All right, today, triangle congruence, SSS and SAS. The next 3 days, we're going to talk about some triangle congruence shortcuts. For some of you who are on the map test, you talked about having these problems. You're going to learn those today. So section 4.4. So section 4.4 here.
Is it like multiple choice?
The first vocab term is called triangle rigidity. All right, not super that we use a lot, but just have the understanding of what triangle rigidity means. It's a property of triangles that states that if the side lengths of a triangle are fixed, the triangle can have only one shape. Okay, so if the triangle's side lengths are fixed, the triangle can have only one shape. What that means here is if you look at my fancy, cool meter sticks, if I give you these 3 meter sticks and I said, hey, make a triangle, and I gave Martina 3 meter sticks that are the exact same size, and I said, make a triangle, how many different triangles can you make? Yeah, you're only going to make one triangle. Okay, it doesn't matter. I mean, you might be able to twist it and be like, oh, hey, let's do a triangle. No, it's the exact same triangle. Anytime you take these 3 meter sticks and make a triangle, you can only get one triangle. And, of course, they go away. Included angle is the angle formed by 2 adjacent sides of a polygon. So the included angle, if you look at, if I have a triangle here, and I know, for example, let's say this triangle, or this has this length of like 6, this one is 5. This one right in between there, if I were to say, that were 70 degrees, that is my included angle. It is between the sides. Okay, that is the included angle. It's included between the 2 sides. Whereas the included side is the common sides of 2 consecutive angles. So again, if I have a triangle here, and there it goes. If I know that this angle is, let's say, 70 again, and let's say this one is 60. This one right here would be my included side. It's the side in between 2 angles. So included angle, included side just means the angle or the side that's in between 2 other angles or sides. Nothing too fancy, just the included angle, included side. We're going to focus a lot on the included angle today. We will talk about the included angle today a lot. Included side will be more on Wednesday when we do the next shortcuts. Okay. So here are some of the shortcuts we're going to talk about today. These are just 2 of the ones we're going to talk about. We're going to talk about what is SSS and SAS. Now SSS stands for side, side, side. It is the side, side, side congruence postulate, which means if you know the 3 sides of a triangle are congruent to 3 other sides of a triangle, then the triangle is congruent. As in, you can only make one triangle. And I kind of showed that with the meter sticks. I can give you all these same exact size meter sticks or yardsticks, whatever you want, and you can only make one triangle. They have to be congruent. No other way around it. They will always be congruent. Okay, and again, these are postulates that state always congruent. Okay, that's kind of something to note. Because we'll get to some today that aren't congruent, and some students are like, but they look to be congruent. They kind of look like they are. And it's like, well, they can look like it, but they're not always going to be that way. Does that mean they can't be? No, they can be, but we're looking for postulates that are always congruent. And side, side, side will always be congruent. The next one we're going to talk, I forgot one part here. If you look right here, now if you look at that triangle, it's triangle JFH and triangle FGH. Now you see JF is congruent to FG, right? It marks that. JH is congruent to HG. It marks that. What other side is congruent here? Tom? What's FH congruent to? Yeah. This is what is called the reflexive property. Okay, reflexive means it's the exact same thing. And we get this, students are like, whoa, how can you get that? No, it's the exact same line. It's going to be congruent to itself. Okay, it is itself. And it kind of states that. FH is congruent to FH. They can share a line. That's okay. Whenever they share a line, it makes it pretty easy because then you know for sure that one has to be the same. Okay, so FH is congruent to FH. We call that the reflexive property. If you want to just say it's the same line, it's the same thing. We're also going to talk about what's called side angle side. Now notice here, again, some students get confused here. It's side angle side for a reason. This would be an included angle, as in the angle is in between the sides. Included angle. If I look right there, included angle. That's what it means. The angle is in between the sides that I know. Okay, and if I look over here as well, included angle. So I have SAS, side angle side. SAS, side angle side. I know that. Okay. It might help for some of you to, when you write these out, kind of write side, angle, side, what you know, because then you can see the postulate that works. Okay, because as of right now, these are the only two we know. We know side, 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 and side, angle, side. Okay, so we're looking for those two postulates. All right, moving on here. Number 1, I want to use side, side, side to explain why the triangles in each pair are congruent. So basically, I'm just going to say, well, how can I know that? How can I see that? So if I look here, I see that JK. I'm going to pick JK right there. What is JK congruent to, Nick?
KL.
Nice job, sir. So JK is congruent to KL because that is marked. This is just explaining it. It's kind of just showing what it all means. JM. Oh my gosh.
Just trying to get on it.
So JM is now congruent to, what's JM congruent to, Troy? To what? LM, very good.
Does it matter?
And I have one last thing. What's the last part that I know is congruent, Jack? What's KM congruent to? KM is congruent to KM. How do you know KM is congruent to KM, Jack? So it's the exact same line. What property do we call that? Do you remember? Start with an R. Reflexive property. That would be the reflexive property. But essentially, you can just say it's the same line. Yes, sir.
Does it matter, like, so like JM is parallel or congruent to LN? Could you just write ML?
Yes, that's fine. Same thing. Yep. Number 2, triangle ABC is congruent to triangle CDA. So, what do we know is congruent on this one, Caitlin? DC is congruent to what? AB. Good work. What's something else you know to be congruent, Gabe? How'd you know that one? Yeah, CA is congruent to CA. It's the exact same line. Recognize that. Because that's one, they will throw that out there a lot on these problems. Triangle congruence, they will almost always throw it out there that they share a line. So recognize that. What's the last one we know then, Kay? CB is congruent to DA. And this, again, this is an example of side, side, side shortcuts. Both these were. Those were side, side, side shortcuts. All right, number 3. Now, I know it's kind of tough with created by Doceri down there at the bottom. But it says, use SAS to explain why triangle XWY is congruent to triangle WZY. So we're going to go in the order SAS, just to kind of show this. Give me one of the sides that you know are congruent, Troy. ZW, right there, is congruent to XW. Nice job. Now I want the angle. So again, there's my side. There's my side. Give me the angle that we know to be congruent, Peyton.
W.
Nope. I can't just say W here because W has technically 3 different angles to it. So give me the more specific W. Bryce? That's a side. I want an angle. Nick? WYX is this angle right down here. So I don't want that angle.
Wait, which one do you want?
I want this one right there or this one right here.
W.
No.
CW.
ZW what?
Y.
ZWY. Good. Now again, why do I have to be more specific here? Because there's more angles. So I have to say ZWY. Now that's taking that angle right there. Do you see that, Peyton? Okay, now I get that angle. What's the other angle that ZWY is congruent to then, Tina? Good. Angle XWY. So that is my angles. So I have SA now. And what's my last side I know to be congruent, Tom? What's WY congruent to? Nice job. So that is an example of SAS. And if you look again, this is my included angles because the angle is in between the sides. Included angles. Okay? That's okay. It's the same thing. You'll be good there. All right. Now, this is a lot what your assignment's going to be like. So take a couple seconds, try these 4 out. Write each of the SSS or SAS postulates, if either can be used to prove the triangle is congruent. If no triangles can be proved congruent, write neither. You will have some that are neither. Let's take a couple seconds, let's look through these here. Number 4. Now watch, listen here. What do I know? I know this angle. Is everybody with me? I know this side. And I know this side. Right? I know this side and I know this angle. So if I look at this triangle, I have ASS. That is what would be called a naughty word. And that is not a congruence postulate. ASS is not a congruence postulate. Number 4 is neither. Okay, and again, why? Because the angle is not an included angle. The angle is on the outside of the sides. Again, write down what you know. I know the angle of the side, that makes ASS. That's not a congruence postulate. ASS does not work. Let's look at number 5. I know a side, an angle, and a side. A side, an angle, and a side. Number 5 is SAS. That's side angle side postulate theorem. Again, write out what you know. Number 6. What do I know for number 6? I know a side, an angle. Is that any of the postulates? That is neither. And the same thing, the other way would have been ASS, which, again, no, we don't have that. We have SSS or SAS. The angle has to be between. Big differences. Number 7, I know a side. I know a side. That means this is side. Nice job.
See, maybe in dumb, I thought it just had to have a congruency tick mark.
Nope.
Yeah.
You have to make sure you're given specific congruency tick marks there. All right, next thing we're going to do is you can prove they are congruent given values or given variables. So, for example, they say, show that triangle JKL is congruent to triangle FGH for y equals 7. Just like anything, what do you have to do with that 7? Plug it in. So you plug it in, you get 13, you get 40, and you get 27, which is what we had on the other triangle. 27, 40, and 13. So it's taking that y equals 7 and plugging it in for my values of y. That's all it is. Okay, and that is showing it or proving it. So just kind of finding what those individual answers are. So number 8, show that the triangles are congruent for the given value of the variable. So I want to show that triangle BCD is congruent to triangle FGH for x equals 6. What am I going to do with that 6, Jessica? Plug it in. I'm going to plug it in there, plug it in there, and plug it in there. So HG equals 2 times 6 minus 3. 2 times 6 is 12, minus 3 is 9. HG is 9. And then I do HF. HF equals, plug 6 in, I get just 6. And then I do FG. Plug it in, 6 plus 2 equals 8. So I had lengths of 9, 6, and 8. 9, 6, and 8. What congruence shortcut would this be, Tyler? SSS. Did you see that? Because they're all 3 sides. So I know all 3 sides, so side, side, side. All right, number 9 here. Same idea. I'm given triangle PQR is congruent to triangle VWX. All right, so I'm going to take n equals 3. What are you going to plug n equals 3 in for, Bryce? Or what are you going to do with that 3? Plug it in. So I'm going to go WV first. WV equals 7 times 3. 7 times 3 is 21. Now I'm going to do the angle. Angle V. Now I can do just V because there's only one triangle. See that, Peyton? Yeah. Now we can do just the V. So I'm going to do 36 times 3 plus 5. 36 times 3 gets me, anybody? 108 plus 5? 113. And then I do XV. XV equals 3 times 3 plus 8. 3 times 3 is plus 8. So I have lengths of 21, 113, 17. 21, 113, 17. Which means my shortcut is what here then, Gabe?
SAS.
SAS. Nice job. That'd be an SAS. So again, that's the included angle. All right, last thing we're going to talk about here. I want to find the value of x so that the triangles are congruent. So I want to find the value of x so that that the triangles are congruent. Now this one, it shows me this angle is congruent. I have the same line here. What do my last two sides have to be? They have to be the same. So how can I solve for x there? Set them equal to each other. Nice job. So 20x equals 22x minus 3.6. And now I just solve for x. So subtract 22x on both sides. Negative 2x equals negative 3.6. Divide by negative 2. Negative 3.6 divided by negative 2 gets me what, Troy? 1.8. Nice job, sir. Try number 11 on your own. Take a couple seconds here, try number 11. Same idea. All right, when you work this one all out, Jack, what do you get for x equal? X equals 17. Nice job, sir. 10 would have been a triangle shortcut of SSS. 11 would have been the triangle shortcut SAS. Again, I know the S, I know the angle, I know the S. SAS. Okay? Here is your assignment. Now, take a couple seconds here, just wait.